Okay, so the bandwidth of the amplifier without feedback is given by BW equal to FH minus FL. When you don't use suffix, you call it as normal bandwidth or normal parameter of the amplifier without feedback. When I'm going to use with feedback, I'll be suffixing F. So bandwidth of the amplifier with feedback is going to be BWF equal to FHF minus FLF. FHF, you know, it is 1 plus A mid beta into FH minus FL by 1 plus A mid into beta. So considering the second term is very, very minimal or negligible, I'm going to ignore the second term and I'm going to write approximately as 1 plus A mid beta into FH. And when there is no lower cutoff frequency, FH will be a bandwidth. So approximately I can write BWF is approximately equal to BW into 1 plus A mid into beta. This is not exact, this is approximate because I am neglecting the second term. Why the second term is neglected? Because it is divided by 1 plus A mid into beta and that value is going to be very, very small. Whereas the first term is very, very larger in number and dominating. Second term is very, very smaller and it is going to negligible effect it is going to cause to the expression. So without any compromising on the magnitude, I'm going to neglect the second term. So bandwidth effective is approximately 1 plus A mid beta into FH. When you have only FH, that FH will be your bandwidth. See, for amplifiers whose response is like this, the lower cutoff frequency is not there. So we'll take the lower cutoff frequency to be 0. The upper cutoff frequency is FH. So the bandwidth is FH minus 0 or it is FH. So if you consider this case, we are ignoring the component of FL. So only upper cutoff frequency is there. So the bandwidth is going to be FH. So I'm replacing FH by bandwidth and 1 plus A mid beta into beta is multiplied by bandwidth. So I can mathematically prove that by applying negative feedback, the bandwidth of the amplifier after feedback is the bandwidth of the amplifier without feedback multiplied by D. See, LF, I divided by D. Okay, I divided by D. FHF, I multiplied by D. Okay, I multiplied by D. Same way bandwidth also, I am multiplying by D. Because this effect is negligible. FLF effect is negligible because it is divided by D and this D is going to be 1 plus A mid into beta and this D is a very huge number. That's why we neglect the value in the second term. So it is approximately equal to the first term. Okay. So if you see this is the frequency response graph. You see without feedback, two things you have to observe. Without feedback, the gain is high, the bandwidth is less. This is with feedback, the gain is less, the bandwidth is